This lecture is about exponents. If you refer to your textbook, it's on section 5.1 and 5.5. There's a few rules that you need to remember in the section on exponents. First one is where we call it the product rule. And what that is where you have two terms that is multiplied together and they have the same base. And what it's telling you is you can actually add the two exponents and keep the base. Okay, now take for example, if you have x cubed and you wish to multiply to x to the fifth power. So equivalently, it's like you're taking x times x times x 3 times, and then x times x times x times x times x 5 times. So in total, you now have 8 of them. Okay, so the shortcut is you apply the rule, and so you think of what's 3 plus 5. So this is what we call the product rule. The second rule that we talked about is called the quotient rule. And what that is if you wish to divide, again, they have to have the same base. And when that happens, equivalently, you can think of it as you are subtracting the exponents. Alternatively, you could also think of it as canceling. So take for example, if you have x squared over x to the fifth power, you could think of it as x times x, 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 5 of them, and you can think of it as canceling. You notice the answer is x cubed, but the x cubed is at the denominator. Okay, and when you cancel numbers, x over x is really 1. So that's why it's 1 over x cubed. Rule number 3 is very similar to rule number 2, and that's the power rule of powers. In other words, if you have a base with a certain exponent and outside there is another exponent, so there is one base, 2 exponents, and that's where you multiply the exponents. So what I was telling you guys in class was when there's 2 base and 2 exponents is where you add. When there's 1 base, 2 exponents is where you multiply. Before we do more examples, let's look at rule number 4, which says that it's the power rule for products. And that just means that if there is 2 terms, 2 bases, that's in the parentheses with an exponent on the outside, you need to distribute the exponent to both of them. Rule number 5 is the power rule for quotients, where if you have a quotient, then you will need to distribute the exponent to both of them as well. So these were all covered in 5.1. And in 5.5, it actually continued the list, and the rule was saying that if you have a base with a negative exponent, what would you do? Okay, and what this means is you have to flip it upside down. So when you flip the term from numerator to denominator, it changes your exponent from negative exponent into positive exponent. Okay, so take for example, if we are talking about 2 to the negative 3, what that means is 1 over 2 to the power of 3. And 2 to the power of 3 we know. 2 to the power of 3 means 2 times 2 times 2, which is 8. So that's why the answer is 1 over 8. Now do not get confused with what happens if this was negative 2 to the power of negative 3. Then you notice the exponent negative 3 is only affecting the 2, which means this is going to be negative 1 over 2 cubed. And that gives it the answer as negative 1 over 8. So observe there is a difference between the negative number and the negative exponent, the two different things. Now what happens if we have the negative 2 entirely in the parentheses with the exponent negative 3? Then in which case we will flip the entire negative 2 to the bottom and raise it to power 3. Except negative 2, when you raise it to power 3, means negative 2 times negative 2 times negative 2, and with that it still ends up with negative 8. And so it just so happened that the answer is negative 1 over 8. Now let's try this. What if this was negative 3 to the power of negative 2? What's that? And try this. What if it was in the parentheses? Now if you look at the difference between the two, in the first scenario, the 3 is the only one that's affected by the negative exponent. So this will be negative 1 over 3 squared. So the answer is negative 1 over 3 times 3 is what we call 9. But in the second scenario, the entire negative 3 is flipped underneath, so it looks like this. And it's raised to the exponent of positive 2. And so the answer becomes negative 3 with negative 3 makes it positive 9. So you notice that these two answers are not the same. Let's look at some of the examples before we continue with more rules. So let's try example number 1. Let's say we are talking about what's 5a cubed multiplied to negative 2a to the 4th power. So all you have to do is take the numbers multiplied by the numbers, which makes it negative 10. And when you apply a cubed and a to the 4 and you wish to multiply them together, that's when you apply the product rule that says that if the two bases are the same, all you have to do is add the two exponents. So you're looking at the 3 and the 4, and it becomes a to the power of 7. And that's it. So let's look at other examples. Now for example 2, let's try if this was negative 2x squared y cubed over 5z squared, and you wish to raise this to power 3. So you're going to have to think about what's negative 2 raised to the power 3, what's x squared raised to the power 3, y cubed to the power 3, 5 to the power 3, z squared to the power 3. So really what you have to do is to distribute the exponent to every single term, piece of the term. And what you have is negative 8. And for this one, because you have one base and two exponents, you need to multiply the exponents, which makes it 6. And in this case, 3 times 3 is 9. And 5 cubed is 5 times 5 times 5, which is 25 times 5, and that comes out to be 125. And for the z, you have to multiply the two exponents, and that makes it 6. Let's try the one with the negative exponents. Like, for example, what if this was negative 2x to the negative 4 raised to the power of x squared? Now remember, the exponent only affects what's directly next to it. So in this case, it's only the x that went to the bottom. So it becomes negative 2 times 1 over x to the 4th, and you wish to multiply this to x squared. So you can look at it as negative 2 over x4 multiplied by x squared, if you like, over 1. So you notice that x squared and x4, they're actually in different places. So you can actually cancel, since one is numerator and one is denominator. And so the final answer is negative 2 over x squared. So what if it gets really confusing, where you have a mixture of different exponents and different bases? So for example, 3 to the negative 4, a to the 5th power, b to the negative 3, over, say, 3 to the negative 5, a, say, b to the power of, I don't know, negative 2. Let's try that. Okay, so what happens is, the minute you see the exponent to be negative, you should switch their positions. So if it's numerator, it goes to the denominator, and vice versa. So with that said, let's go down the line. 3 to the negative 4 is brought to the bottom. A to the 5th stays on top. B to the negative 3 goes to the bottom as b cubed. 3 to the negative 5 goes to the top as 3 to the 5th power. A in this case, it means exponent is 1, so it stays at the bottom, and the b to the negative 2 goes to the top. Okay, so there you have it. You've moved all the terms, and you've turned all the exponents to positive exponents. So now we can start canceling. There are 4 3's at the bottom, and there are 5 3s on top. So when you cancel, there's going to be 1 left on top. For the A's, you notice there's 1 A down here and there's 5 on top. So you're going to cancel and it leaves you with 4 A's in the top. And for B's, there are 2 on top and 3 below. So that makes it 1B left at the bottom. So your final answer is going to be 3A to the 4th power over B. Let's try one more example. Supposedly we have 2x to the negative 2y squared, and you are raised to the exponent of negative 2. What would you do in this scenario? So for you to deal with this, you might have to consider rule number 7. And let's continue the list of rules. Rule number 7 says that in the event if you have a fraction with a negative exponent, you can actually flip the entire fraction over and make the exponent positive. So that's probably what I will think about, because what I'm going to do now is I'm looking at 2x to the minus 2y squared, and I'm looking at it as over 1. And what I'm doing is I'm keeping the 2 and the y squared on the top, but I'm sending the x squared to the bottom. Okay, but the exponent is still negative. And then what I do is I'm going to flip the entire fraction around, so the x squared goes to the top and the 2y squared go to the bottom. But in doing so, the exponent has turned from negative to positive. Okay, so that's applying rule number 7. And now if I square each term, it makes the answer x to the 4th over 4y to the 4th power. So that brings me to rule number 8, which is the last rule in the book. And this rule is saying that anything to the power of 0 is always equal 1, provided the base is not 0. Okay, so what this means is, for example, if you have 5 to the power of 0, that's 1. 1.5 to the power of 0, that's still 1. If you have negative 3 to the power of 0, that's still 1. But watch out, the negative is in the parentheses with the 3. Because what if there is no parentheses and it's negative 3 to the power of 0 like that? Then this is back to what we talked about. The exponent only affects what's directly underneath it. So in that case, this is the piece that's equal to 1. But the negative stays. So the final answer to this one is going to be negative 1. So let's make sure you understand what we've been talking about. For example, if you have 5 to the power of 0 minus 2x to the power of 0 plus, let's say, 7x, the entire thing to the power of 0, how much is that? So let's go down the line. 5 to the power of 0 is 1. But look at this one. You notice the 2 is not affected by the 0. So it's going to be negative 2 times, and x to the power of 0, this piece is 1. Plus, now this is a different scenario because the entire piece is affected by the exponent 0, so the entire piece becomes 1. So what I have is 1 minus 2 plus 1, which makes it 0. The next thing we need to talk about is what do we mean by simplifying like terms. The reason why we're studying exponents is we need to identify clearly what is considered to be like terms, and exponents directly tells us in a way what is considered to be like terms. Okay, so not only does the variables, so variables and their exponents must be exactly the same. So we're not just looking at the variables, we are also looking at the exponents, not just the base, also the exponents. So take for example, if you have 5x cubed y and 2x squared y cubed and let's say 7xy squared. You notice all of these terms, they have x and y's in them, but the exponents are all different. Okay, so these are not like terms. So take for example, if you have 5x cubed y, you have negative 2yx cubed, you have 7x cubed y, then these are like terms. Okay, so what determines like terms is not just the variable, but also their exponents. They have to be exactly the same. So what happens if they are like terms? And what you're going to do is you are going to add and subtract, add or subtract their coefficients, which is the number in front of the variables, but you must keep the variables and exponents. So that's what we mean by simplify like terms, as in combining like terms. So let's apply everything we've learned so far and apply it to this problem. So take for example, if we say, can you simplify, let's say 3x cubed, 3x squared y with a squared, minus 4x, and then x cubed y with a square. So before you can decide if these are like terms, you have to simplify them first, and these are multiplication, whereas that's exponents, so you have to deal with exponents first by your order of operations. So 3x squared y, when you square it, gives it 9x to the 4th y squared, minus 4x times x cubed y, when you square it, makes it x to the 6th y squared. Now this is multiplication, so I have to continue further multiplying them, numbers with numbers. 3 times 9 makes it 27. X cubed and x4 combines to become x to the 7th power y squared, minus, now in this case the x's combined, so I'm going to work this out, and it becomes 4x to the 7th y squared. Now at this point is where I'm looking at the two terms, and I notice that their variable portions are the same, x7 y squared. Okay, so what I'm going to look at now is the coefficient, which means 27 minus 4. So I'm looking at these numbers, and that makes it 23. So that's when I'm subtracting the coefficients, but keep in mind you have to keep the variables. Okay, so you are only adding and subtracting the number in front of it, but you're keeping the variables. This is back to what you have seen before. For example, what's 3a minus 2a? It becomes 1a. Or things like what's 4b plus 5b? That makes it 9b. So this is what you've seen before in your earlier math, except that here you're not just looking at one letter, you're looking at a few, but it's the same thing because the letter portion just determines that they are the same kind, okay, that they are actually the same family, they're like terms, and what you're doing is you're combining how many there are. So instead of 27, because 27 when you subtract 4 becomes 23, for example. Okay, so this is what you call simplifying like terms.